Hi there, this is René for GNS 3Volt, and in this video I'm going to show you how to solve the EIGRP beginner lab. So this is the topology that we have. There are three routers connected in a triangle like this, and if you are able to do this lab, then you have a good understanding for your CCNA exam. So we'll take a look at the goals that we have, and I'll walk you through the configuration. First of all, configure EIGRP on all routers. Achieve full connectivity. So, and of course we also have to create a loopback. So these are the loopback interfaces that we need to create. So let's have a look. Router X. I'll start with the loopbacks here. So let me check. That should be 1.0. So I'll just pick the first IP address over here. That's one loopback. Router Y has a loopback. And we'll pick .2 like this, and router Z or Z, or however you pronounce it in English, 16 3.3. So there we go. Okay, so those are the loopbacks. Let's continue and enable EIGRP on all of these routers. So EIGRP, and the AS number should be 100. Router EIGRP 100. Network uh, 12, 13, and the loopback. So keep in mind the network command does two things. First of all, it will enable EIGRP on the interface. So by using this network command, EIGRP will be enabled on this interface. And by enabling, I mean that it will send hello packets out of the interface. So if you send hellos and you receive them, then you will become EIGRP neighbors. And second of all, it will also advertise this network. So you can see as soon as I type in the network command, it's forming a neighbor adjacency. Last router. And there's a shutdown command here on the interface, so I shouldn't forget to get rid of that. No shut. Okay, so you can see all the EIGRP adjacencies here. Show IP, EIGRP neighbors, and you can verify the neighbor adjacencies. So that seems to be working. Okay, so the next step. You notice that when you start a ping from router Y's loopback to the loopback of router X, that this is not possible. You need to fix the problem. So if I ping from the loopback of router X to the loopback of router Y. So let's see what is going on here. So that's router X, this is router Y. This is the IP address of the loopback. Let's try this one first. So ping 172.16.2.2, that's the loopback of router Y. And you can see that my ping is failing. Now, why is this failing? Let's do a show IP route. And we'll take a look at the routing table here. So what can you see if you look at this routing table? First of all, I see a C for directly connected. So this is my own loopback. And you can also see the D for EIGRP over here. And it says 172.16.00/16 is a summary. And it points to the null interface. And the reason you see this is because by default EIGRP has auto summary enabled. And this means that by default it will advertise networks as class full. That means that if you look at the loopback over here, my loopback is 172.16.00/24. That's the network address. But by default this is a class B network. So what EIGRP does by default is advertise 172.16.00/16. So what I need to do to fix this problem is I need to disable auto summary. So go to your router, type in no auto summary, and you need to do this on all of the devices. Router EIGRP 100 no auto summary. EIGRP no auto summary. Okay. Now after doing this, take a look at the routing table again. And now you can see a big difference. First of all, you do not see the summary route pointing to the null interface anymore. And now you can see that EIGRP advertises the network, but also with the correct subnet mask. So now you can see 172.16.2.0 and 3.0, and those are the loopbacks from the other routers. So I should now be able just to send a ping, and you can see that it's working. So keep in mind, EIGRP by default has auto summary enabled, and I think this depends on the iOS that you are using. I believe if you use iOS 15, the newest version, I think it has auto summary disabled by default. Anyway, that's working now. The next step, change the bandwidth. So traffic from router Z or Z, I really have no idea how you pronounce it in English, to router Y's loopback interface uses the link between X and Z. So change the traffic from Z to Y. So that's the router at the top, bottom right, Z to Y. It should not use the directly connected link, but it should use the link between Z to X and then to Y. So how can we do this? Let me show you. Let's go to router Z, show IP route. So this is the loopback of router Y, and you can see that it's using this interface, which is the directly connected interface to router Y. And the reason we are using this is because this is a shorter path than the path through router X. Now we can do two things. First of all, you can look at the EIGRP topology table, and you can see over here that there is only one entry for this network, for the loopback. So the directly connected link is my successor, and there is no feasible successor. Now what I can do is I can go to the interface and I can change the bandwidth, and we can make it, let's set the bandwidth to a very low value. So let me just set it to 10, and we'll see if this makes any difference. So show IP route. You can see it makes no difference. Well, it does. I was just too impatient. So this was the entry before I changed the bandwidth. So in order to reach this network, this is the interface that we were using. And now you can see that we are using the fast Ethernet 0/0 interface. and that's because the bandwidth has changed. So by changing the bandwidth, the path from Z to X to Y is now a better path than from Z using the directly connected link to get to Y. So you can change the bandwidth to influence this a little bit. It will influence the metrics. Okay, so we did this. I changed the bandwidth. The next step, change the EIGRP configuration on all routers, so load and reliability are also used as metrics. So if I go to a router and we can do show interface, doesn't matter which one. Over here you can see the MTU, you can see the bandwidth, delay, you can see reliability, and you can see the load over here. Now EIGRP can use 4 of these values. It can use the bandwidth, delay, reliability and load to calculate a metric. And by default only bandwidth and delay are used. So what I can do is enable reliability and load as well. What you have to do is go to router EIGRP, metric, weights, and here you have to specify a couple of values. The first one is easy. It says type of service. Only type of service 0 is supported, so that's easy enough. And then it asks me for the K values. So what does this mean? The K values that we have, they stand for bandwidth, delay, load and reliability. And this is something you'll just have to remember. But K1, that's the bandwidth. And you can also set what the value should be of this value. So do you think bandwidth is very important or not so important? That's up to you to change here. But what I'll do is I'll set this to 1. So that's bandwidth. K2 is load. I'm also enabling it. K number 3 is delay. I'm also enabling this. K4 is reliability. I'm also enabling it. And K5 is also there. This is the MTU. And MTU you have to specify it, but it's not being used for the metric. So I'll set it to 0. So by doing this I'm enabling bandwidth, delay, load and reliability. You can see my neighbor is a little bit pissed off because it says K value mismatch, interface received a goodbye and so on. These values have to be the same on all of your routers. So we'll just copy and paste them. Make sure all of our routers use the same metrics. There we go. And as soon as I change the metric, you can see that it's that my neighbors are working again. Okay, so far so good. So load and reliability have also been enabled. Next step, router X, create a summary towards router Y and Z for the 172.16.1.0 network. It should appear as 172.16.00/16. EIGRP is pretty cool. You can create summaries per interface and it's easy to do this. So what we will do is go to router X over here, go to the interface and you'll type IP summary address, EIGRP, AS100, and here you can just type in your summary. So we'll do it like this. And I'll also do it on the other interface, like this. Now if you look at router Y, for example, show IP route, you can see the summary over here in the routing table. 172.16.00/16. So you can do this per, you can create a summary on an interface. Alright, so we did this. Last step, configure EIGRP authentication on all routers. The keychain should be called XYZ and the key ID should be 1. Password should be vault. So let's create a keychain. key chain XYZ, and here you can configure the key. So key number 1, and then you need to specify a key string, and the key string is just the password. Exit. Let me show you this one more time. So this is what the keychain looks like. Keychain XYZ. The name of the keychain is only locally significant. So if you use a different name on different routers, it really doesn't matter. The key ID has to be the same, and this is the password. So this obviously has to be the same on all of your devices. Now let me copy and paste this to the other routers. Like this. So now they all have the same keychain. And the next step is to enable it on the interface. So what we have to do is say, let me think, what was it again? IP, not IP. Well, that's a good one. Let me think how we can do authentication again. IP authentication, keychain. Okay, so that's it. IP authentication, keychain EIGRP 100, and the name of the keychain was XYZ. That's how you specify the keychain. And the second step, IP authentication mode EIGRP 100 MD5. So there are two steps to enabling the keychain. Let me show you the config again. So on the interface, you have to specify which keychain you will use, and you need to specify that you want to enable authentication. So what I'll do is just copy and paste this to all of my interfaces. There we go. So you can see the adjacency goes down and it's back up again. That's because one side had authentication and the other side didn't. But everything should be okay now. So you can see that I have my neighbors again. And that's it. So that's how you can configure authentication. And if you use the keychain, there is one more thing that you can do. It's possible to create a what was I going to say? Keychain. Oh, sorry. Yeah, the timers. If you use a keychain, so key ID 1 as just a password. What you can also do is specify that a key is only valid from a certain date or a certain time until another certain date or time. So, for example, I can configure key 1 to be valid from 1 June to 14 June. And key ID 2 can be valid from 14 June up to 28 June. And the idea behind this is that if you have multiple keys, then you can say, okay, key ID 1 is only valid for this month or for this day, and once it expires, then we need to switch over to another key. Which of course is security-wise a good idea, but on the other side you'll have more work because you need to create multiple keys and configure the expiration date of the keys and so on. But I'll just show you an example. What I'm going to do in this video is just configure key ID 2 and I'll set the validation date. So I'm not going to change key 1 now because it will kill my EIGRP adjacency. Keep in mind before you do this that you set the correct time and date and so on all your routers, and it's best to use an NTP server for this, so all the routers will synchronize and have the same time. Anyway, let me change the keychain. So keychain XYZ, key number 2, And here you can say accept lifetime for the 14th of June. You can set a time. Let's just think up a time, doesn't matter too much. 14 June 2010. It's been a while since I created this lab because it's already 2012 right now. And so that's the accept lifetime, and now you can say, okay, when does it expire? Never, or a certain date or time. So let's set it to 9 o'clock, and it should expire at, what was it? The 28th of June. So 28 June 2010. That's it. Show run, section, keychain, and here you can see that key number 2 has an accept lifetime. It starts at 9 o'clock the 14th of June and it will expire at 9 o'clock the 28th of June. So that's it. And normally if you do this, because key 1 will be used by default, you can see it doesn't have a start or expire lifetime. So key 1 will always be used by default. Key 2 will never be used because it will start with the lowest key number. So if you want to do this on a production network, you need to make sure that key 1 will expire as well. And once it expires, key 2 can take over. Anyway, let's just copy and paste it to all of the devices. And that's the last thing that I will do. So I think that's it. So I did all the tasks and I showed you everything that I wanted to show you. If you have any questions, please leave a comment. I hope you enjoyed this video. Thank you for watching and till next time.